Okay, so now we're going to talk about simplifying powers of I. Now, whenever we have I raised to a power, because I is defined as the square root of -1, it's that imaginary unit, we're going to be able to simplify those powers if the power is ever bigger than 2. So if you have I to an n power, if n is bigger than 2, greater than or equal to 2, you must simplify it. And we're going to talk about how to do that. Now, before we do that, let's go ahead and talk about what the power would look like if we had, say, like smaller than 2. So if you raise I to the 0 power, you're raising a number to a 0 power. And one of the rules you learned in Algebra 1, we talked about a little bit earlier this year, is whenever you raise anything to a 0 power, that is the same thing as 1. If you don't remember why that is, I can show you again. Just ask and I'll be happy to. Now, whenever I raise I to the first power, whenever you raise anything to the first power, you get itself. So I to the first power is going to be I. Okay, so those are like the baseline things we're going to use. So now let's talk about I squared. Now I squared, remember that I is the square root of -1. And we talked about in that last video, in order for this to be true, for I to be the square root of -1, that means that when we square it, we should get -1. Otherwise, it's not the square root of -1. So I squared is -1. Now, this is where it starts to get a little trickier. Let's talk about I cubed. Now, I cubed means I times I times I, right? So if I look at this, I can regroup this as I times I, which is I squared, times the single I over here. And what we just saw in the previous step, I squared is -1. So this is -1 times I, which we would simplify as -I. So right now I've got I to the 0 is 1, I to the first is I to the second is -1, I to the third is -I. Now, when I hit I to the fourth, something interesting happens. I'm going to write I to the fourth as I times I times I times I. Now, if I did what I did in the previous step and regroup these first two terms together and these second two terms together, that would give me I squared times I squared. And I squared, remember, was -1, and I squared was also -1. So when you multiply those together, you get 1. Now I want you to notice that anytime I have I to the fourth, that's going to give me +1. So if I go to I to the fifth now, I could group those first 4 i's together and make that 1, and that would be 1 times I, which comes out as I. Now, notice, I started, I to 0 is 1, I to the first is I, and now I've hit a pattern where I've hit 1 again at I to the fourth, and I at I to the fifth. So what do you think I to the sixth is going to be? Well, look at the pattern. The next, if I rewrote it the long way, I to the fourth times I squared, I to the fourth is 1, I squared is -1. So when you multiply those things, you get -1. I to the sixth is -1, which is exactly what I squared was. So you see we've got a pattern going on. 1, I, -1, -I, which is right here. And then it repeats again. 1, I, -1. So I to the seventh is going to be -I. I to the eighth, 1. I to the ninth, I to the 10th, -1. I to the 11th, -I. And so forth and so on. So if I have some sort of big power of I, like I to the 57th, now I could do this process and I could say, hey, I've got an I to the fourth, let me pull it out. Now it's 1 times I to the 53rd. Oh, I have to pull another one out. It's another 1 times I to the 49th. Oh, I have another one. And I can keep doing that, but that seems kind of like long to do. So what I'm going to do is this. I'm going to take the 57th, which is the power, and this pattern is 1, 2, 3, 4 things long. So I'm going to take that 57, I'm going to divide it by 4. I'm going to do it by hand and not with a calculator. You'll you'll see why in a moment. So long division, multiply, divide, subtract, bring down, divide, multiply, subtract, nothing to bring down. So I have a quotient, the answer is 14. This 14 is the number of groups of 4 i's that could be put together from these 57. So each of those groups is going to be a 1. So basically I have 1 times itself 14 times, which is just going to give me 1. So this part I'm not really interested in, because it's just going to be a bunch of 1s times a bunch of other 1s times whatever is left. What I'm really interested in is how many i's are left in the end. So what I'm going to do is take my power, divide it by this pattern of 4, ignore the quotient because those are all going to give me a bunch of 1s multiplied by each other, and instead focus on how many i's I have left. That remainder becomes the number of i's, which is the power on the I, and then you can look at your initial pattern of 4 and see where it falls in that pattern. So this would be I. So I to the 57th then is I, because it's the same as I to the first. Here, let me show you one more. So let's say I wanted to find I to the 99th. I'm going to take the 99, divide it by 4. It's going to be a 4, 16, 3. I'm going to ignore the quotient because that's 1 times itself 24 times, which is basically another 1. And instead, I'm going to focus on the remainder because that's how many i's I have left. So I to the 99th would be the same as I to the 3rd, which if you look at the previous pattern is negative I. And that's how you simplify powers of I.